Hello, my name is Scott Parello. I'm the COO and a partner with the Building Envelope Group. Thanks for joining me today. Today, we're going to discuss estimating basics. More specifically, we're going to study an example project for a wet glazing installation. So thanks again, and let's dive in. So before we get into the specifics of the estimating process, I'll just show you a couple of photos of the building in question that we're going to study. This is a downtown metropolitan city in the United States. And we're going to just basically on these two elevations of this Class A office building, 21-story Class A office building, we're going to be performing wet glazing, where we remove the gaskets, where we actually slice the extrusion part of the gaskets, where you can see in this photo where they're either missing, hanging out, deteriorated. So what we basically do is you have two options here. Either remove them completely and install all new gaskets, which is extremely cost prohibitive, or basically slice them back to the face, clean up the surface, and in wet glaze by installing liquid joint seal and silicone that is tooled to that shape, and it'll provide the same sort of cushion that the existing gasket was supposed to do. So that's basically the scope of work. So again, we're going to focus on these two elevations only. We're going to access with swing staging, suspended from the roof, and we're going to do 100% of all of the gaskets on both of these elevations and provide overhead protection for the downtown residents for safety. So just some of the numbers and assumptions we're going to make. Again, it's a 21-story Class A office building in a downtown city. We're going to remove 100% of the gaskets or slice back 100% of the gaskets and perform wet seal on all of them. And the term wet seal, wet glazing, they're basically synonymous term to mean, the installation of joint sealants from a liquid form instead of a pre-cured rubber gasket. So one side is approximately 260 linear feet long, and the other is about 210, totaling 470 feet if you add up both sidewalks or both elevations. Each window, we're assuming, is approximately 8.5 linear feet wide by 5 feet tall, which would be about 27 linear feet of joint each. Plus, we're going to round that up about a half a foot. That will accommodate for the miscellaneous metal frame butt joints. If you remember in the photos, some of the the metal frame assemblies where they met each other, there was a small 2-inch section. So each one might have 2 or 3 of those where we would have to install the silicone joint sealants at that location. We're assuming all of the wet glazing joints will be 1/2 inch wide. The width is important as far as the amount of material we're going to use, and it would be a fillet joint. So instead of an expansion joint where it's a straight joint, we have 2 open ends that you would have backer rod behind that. This is an inside corner, so like a 45-degree angle type of a joint. Sometimes bond breaker tape is required behind there to prevent 3-sided adhesion, but that's not always required in these cases because where it will be hanging over the existing gasket assembly would often form as a bond breaker. So just counting up the panels, we're making the assumption there's 38 panels high by 54 wide, including both sides, totaling 2,052 panels. If you multiply that by the 27.5 linear feet each, it's 56,400 linear feet in total of wet glazing. So we're assuming 5 swing stage drops on one elevation, 50-foot swing stages. So that's where OSHA, kind of gives you the limit on the width of a swing stage. If you have a traditional swing stage with hoists, that's the furthest you can basically be between the two. Sometimes they use 30-foot stages, 40-foot stages, 50 would be the max. So in this case, I'm assuming using the max because it's just light duty caulking, not a lot of heavy materials or anything. So you could put 3 workers on each stage and be pretty productive on that. So 5 drops on one elevation, 4 drops on the other, 9 total drops. We're also assuming overhead protection. Obviously, we're downtown over a city, and most cities major cities regulate the type of overhead protection you can have down there. You can't just have lightweight scaffold with some, planks and plywood on top. You need a heavy duty assembly in most cities. So these costs, I'm making an assumption. Every location is going to be different depending on the municipality, depending on permit fees, depending on a lot of factors. This is just an assumption based on my experience in some metro areas. So we're assuming $125 per linear foot. That would cover the erection, the dismantling, engineering, permits, and it's also the first month rent. And that would total $58,750. We're going to make the assumption $35 per foot or $16,450 per month for every month after the first. And we will figure out the duration as we perform the estimate. Okay, so let's get into the actual estimating process. So this Excel spreadsheet that you see, I developed this over the course of a number of years to try to find a simplified way on simple scope projects such as this, where we could have an entry-level form to learn the estimating process, but still have everything covered in here in a robust format that's easy to follow. So there's a number of tabs on here, and I've put this together for any type of joint sealant application, whether it be expansion joints and wet glazing or just wet glazing or whatever it may be. I also am developing some other ones for coatings and cleaning and that sort of thing. But so and all BEG members will have access to this. And basically, so in the first tab, I run through a set of instructions so that, when the user is, kind of getting used to the format, they can refer back to this and make sure that they thought of everything they need to on each tab. But basically, I have it, you have your instructions tab, I have material coverage, and this is a good tool, which we'll get into for a moment, not just for figuring out, how much material you need, or, this really doesn't get into the costs. This just figures out per footage based on certain joint widths, how much material you're going to use. And after this could be used for actually purchasing materials, whether you're using sausages or cartridges or bulk. And in joint sealants, typically in large commercial applications, you're going to use the 20-ounce sausages. You can use 10.5-ounce cartridges as well, but this is pretty much, and that's why I've highlighted in yellow, pretty much the one most folks are going to use. We'll be getting into the labor hours based on certain production rates I have seen on average. We'll be discussing the rigging itself. Whether you perform this in-house or you have a third-party person setting up the rigging, this is a good way to come up with a budget for that from experience. And then caulking materials. We'll be getting into the price, using unit prices that I've recently put together based on an average for a given metropolitan area, and for specific other areas where you may be located, we can adjust that based on the cost that you're receiving. We're going to total that up regarding just basically the caulking labor and the caulking materials. And then we will total all up and add in additional overhead protection costs and any other types of things. So first thing we need to do is determine the scope of work. From the estimate request or report, whatever your process is on how the scope is developed, we need to understand what the scope of work is, obviously. If there's any drawings or specifications, if there's a third-party engineer. So once we figure that out, and we've determined for this project it's going to be a wet glazing application, we must perform a quantity takeoff survey in the field and coordinate with any drawing. So a quantity takeoff is an estimating term which really kind of stems from drawings, where you would highlight certain areas on the drawing that you're taking off the quantities so that you don't count them twice and you don't miss them. So that's what that term kind of means. But that's basically getting out there and measuring every foot of joint, and or every square foot of whatever the process is, or every each, or whatever the quantity is, and the measure of quantity is. We must go out there and make sure it's accurate. So I will get into much more detail when we do other types of joint sealant estimating activities, such as the type of substrate. It matters because the rougher it is, usually the longer it takes to remove existing and even to do install. In this application, we're going to focus mostly on the wet glazing line items here. And you can see on a typical sealant replacement project, determine the quantities for linear foot of wet glazing and the average joint width. Well, we've already made those assumptions. We're assuming half-inch wide, and we already have the quantities, which I previously mentioned. So basically, the first step is to open the material coverage calculator tab. And it's for informational purposes only, as I said before. But this calculator can be used for material purchasing during construction phase. Or for special pricing during estimating. So often if you're going to do a large project, and maybe they charge you, I don't know, $10 a sausage for a given product. If you're purchasing a large quantity, often you can reach out to the supplier and you might, save 50 cents or $1 per sausage, on a large purchase. So these are things to keep in mind, and this is a nice tool to have for that. As you can see, we have this kind of broken out. So for our project, we really only have one line item. So we have an option for expansion joints, as we said before, or fillet joints, which is what we're doing, wet glazing. And as I said before, we have 56,430 at a half an inch. So let's do that, 56,430. And you just hit enter, and then there you go. So if you kind of go over there on this, over here under sausages, based on that, anticipated coverage rate, which was calculated just based on the science and the shape of the joint, we expect 1,881 sausages will be needed on this project. Down below, I've put in a lot of just estimating information. This is just physics. There's 231 cubic inches in every gallon of any liquid material. That's just the laws of physics. So, if you sit there and kind of use these formulas, you can figure out, what you need for a lot of different applications. But this tool has already been kind of factored for you. So the thought has already been handled. So that would be that tab. So now we want to open up the caulking labor tab. We want to review the default sealant mobilization man-hour cell. We'll talk about that. We want to enter the linear foot quantities, as we talked about. We want to review the daily production rates. We want to review the default crew size. We want to review the totals for the project duration and labor hours. And then we want to review the duration as it relates to swing stage and other rental periods. So let's get into that. So as you can see, there's multiple options here of labor that you can perform. So we have mobilization. Now, this is not the swing staging. That'll be handled in another tab. So this isn't where, the workers will come and put the rigging and everything on the building and the swing stage setup. This is mostly pre-mobilization stuff. For a large joint sealant replacement project, regardless if it's wet glazing or what it might be, you typically want to do pre-construction testing. Where you would install a few mock-ups, maybe with primer, without primer, with different types of prep, maybe different colors, so the owner can see them in place. So I usually throw in, basic 16 man hours. This is pretty typical. Maybe it's a lead man for a couple of days. It's probably a little heavy for some projects, but and you can adjust this as needed. For this project, maybe it's a little heavy because it's really just a wet glazing project, and we're probably going to use bronze or black. And it's wet glazed and not a lot of different primers. So on this particular one, I might even drop that down. I have a default of 16. I might just make that 8. And then wet glazing. So we're not going to do the expansion joints or perimeter joints or anything like that. As I said before, we have 56,430 feet. We're just going to pop that in there. All right. So this is the daily production rate that I've put in there. Now, for new BEG members and with crews and teams that are, probably coming up to speed on learning, their skill set. Now, obviously, you're going to have access to qualified subcontract labor and things like that, where production rates might be improved. This is a good baseline amount per day. Let's remember, the basis of estimating this type of work, it's assuming that the mechanic or journeyman level person, that's basically a person with, 3 to 5 years minimum of experience, what the average mechanic can produce in an 8-hour day. Some folks will be, more productive, some may be a little less productive, but based on the average rate of pay in that particular market for, like a journeyman level person, about 5 years experience, give or take, this is what we would expect on average. I have put that production rate per hour as high as 40 feet per hour, or over 300 feet per day, and I've gone a little bit less than 250, 240 as well. So we're starting kind of a lower production rate, but I suggest start here with the numbers I've put in here. These are pretty much industry average rates, and then we can see where we go from there as you track production quantities from project to project. And if you find your teams are blowing this stuff away, then hey, you can be more productive and raise that to 260 a day or 300 a day, which is possible. But for now, we're just going to leave that. So we have the 56,000 feet. That's the amount of man hours, and plus the 8 hours plus that, we have our total man hours, and that's already been populated down at the subtotal summary, as you can see right here. So now we just take a look here at the crew size, because this is saying, all right, we're going to have a crew size of 2, which is kind of default for a small large project where maybe the swing stage sizes won't accommodate 40-foot stages or 50-foot stages. But I think on this project, because of the straightforward nature of the facade, there's not a lot of, ins and outs in small sections that smaller swing stages are needed. You could definitely have 3 folks on each swing stage. Secondly, we're going to get into the fact that we're probably going to want, overhead protection, and that's pretty expensive. So we want to limit the duration of time. So if we can put more manpower on this project, that would be ideal for the duration of permitting, overhead protection costs, rentals, things along that order. So for this project, I'm actually going to say 3 per stage, and I'm going to assume 2 swing stages. So I'm going to push this up to 6. So now you can see what it astronomically did to the duration. So all things, equal, we went from 5 months for 2 guys down to less than 2 months. That's going to make a big difference. Of course, when it comes time to award of the project and, scheduling and mobilization, you may not have that manpower available, and you might have to pivot a little bit, maybe put 1 stage with 3 guys, and, but let's assume for this job, that's what we're going to do. Okay, rigging. As I showed you before, it's a pretty straightforward, rectangular building, downtown office building, 2 flat walls, curtain walls, flat roof with a penthouse assembly in the middle. We're making the assumption that there's certified roof anchors and structural elements to tie to and rig to, and we'll get it. We can get into rigging in another video and training session. But so basically what we're saying is, all right, so we want to mobilize the swing stage. So now for this example, we're assuming we're going to do 2 50-foot swing stages. We might put one at one end of an elevation, one at the other end, and work towards each other in the middle. Or we may want to just do overhead protection on one of the streets and do 2 swing stages on that. And a lot of that depends on the scaffold subcontractor. If you've used one for overhead protection, what those costs would be. Are they going to charge you more to come out there twice? So there's a lot of factors there. Let's just assume for this project, we're going to put full overhead protection on both, and we're just going to try to bang this thing out. Maybe 1 swing stage on one side, 1 on the other, and they work towards the middle. So my default is typically 40 hours for mob and demob. And really what that usually means is 3 guys for a day to mob, to get the swing stage up on the building, and maybe 2 guys for a day to take it off. So that works at about 40 man hours, give or take. This job, we're going to be putting 2 swing stages on, but the rigging seems pretty simple. There's not any tiers or anything on the building. It looks pretty simple access. So my gut says let's just leave this at 40 hours. Okay, now, as I said before, that will be the first drop. So at the end of this process, the crew has set the initial swing stage, or swing stages. And in this case, we're assuming 2 are already on the building. So when they're done with this, that includes the labor for setting up the first 2. So as I said before, there's 9 drops. So we still will need to move 7 more times, because that's 9 minus 2. So let's put 7 in here. Those are additional drops. And then we're trying to figure out, well, how many man hours per drop? Typically, if you have 2 or 3 guys on the stage, it's not going to take you much more than, especially on this job, about an hour and a half at the most. An hour and a half for 3 guys to rig over, which is really, if they're using beam and weight assemblies, loosen that up, take those off, slide it over, loosen the cables, swing that over. So typically a crew can bang that out in about an hour and a half. So I have 5 man hours per drop, and I wouldn't change that. So one last item, we could add additional rigging hours if we wanted to, because sometimes on a lot of buildings, you'll have pretty simple rigging throughout the length of it, maybe 80% of it, but sometimes they may be like tiered, elevations at the ends of the building where the rigging has to be completely removed, moved down to a lower floor, brought out on a dolly and protection and all this kind of stuff. So this is where you would throw additional rigging hours, and you can kind of study that and figure out what additional time you'd need and enter it right here. But in this case, I don't see that necessary. So as you can see before, this is based on the crew size. So I set this based on what we set back here, the amount of crew we have. So 75 rigging hours total, which will show up at the end here in total hours. So that's pretty much it for rigging labor. All right. So now the materials, caulking materials. So basically, I've gone through and got unit prices for various materials that we could need. In addition to primers, backer rod, bond breaker tape, miscellaneous, solvents and things like that. And I've come up with the average unit prices based on the widths of the joint and the profile of the joint. A straight joint with backer rod behind it will use more sealant than a fillet joint, which is an inside corner. And obviously a 1/2 inch wide joint will use less material than a 3/4 inch joint. So as we said before, we're not going to be getting into expansion joints or perimeter joints or anything along that order. We're just basically focused on wet glazing. And we said 1/2 inch wide. And again, the magic number again is 56,430 feet. And based on that 80 cents per foot should cover you for all of those things we talked about. Primer, if needed, solvents, bond breaker tape, it's kind of all thrown in there. So we have a total of material costs of $45,144, which is brought down here, and it is pushed forward to this line item. So as I said before, we're just focused on wet glazing. So now we're at the summary page. So what are the things we want to do on this one? Obviously, we want the name of the building, estimate number, whatever that is your process. We're just starting to look at some of the stuff you don't have to fill out. This is done automatically from the previous pages. So based on everything we've installed with rigging and everything, we're looking at less than 2 months, 40 work days. I'm also throwing in some additional hours for project supervision. So basically what that usually means, this is direct supervision, but typically on any job, you're going to assign a foreman, a foreperson, and that person will have some non-productive time, mostly a working full person. But basically, every day they're going to want to do something, maybe get with the owner, check in, may have to do some quality control on each swing stage, maybe bounce back and forth, do some different things. So from my experience, I usually add in about an hour per day of non-productive time for that working foreman. And that time is not reflected in the productive tasks in caulking. So you need to recoup those costs. If he's spending 5 hours a week, for 2 months, that adds up. So you need to capture it. So that's what I do there. And anything else you could throw in there as well. And you can see down here if there's any additional time, like say for additional mobilization or daily cleanup or anything along that order. This is a pretty straightforward caulking job, so the cleanup will be handled in real time with the wet glazing application. Throw it on, in a bag on the stage, and you're good to go. Direct supervision, basically that's just calculated from above. So now this is important. This is the average hourly cost for labor, burdens. Now, so every market's going to have a different, hourly rate, which is typical in that area for mechanics. So this is making an assumption in this given marketplace that the average mechanic check rate would be maybe around $25. And then when you add in burden, FICA, FUTA, SUTA, and all that, and other, employee costs, average it to $30 per hour. Now, on the flip side, if you work with small subcontractors, like I have in the past, I try to find smaller guys that can sell their labor to you for about the same cost as your burdened rate. And what they do is they make money off that by having different team members at different rates of pay, and it can average out where they make a few dollars per hour of each one. And if you could sell it for 30, fantastic. Even if it's 35, you might take a hit on some gross margin, but you can still get the job done if they're qualified. But that's what this is based on, because really what it is you need to be competitive in your marketplace. So we're assuming $30 per hour here in this particular place. So it all calculates out for you. You don't have to change anything unless you want to change the 30. I wouldn't change that here in this case. Everything regarding materials follows through. Are there any additional materials costs? Well, I mean, are you going to need extra materials for the rigging? Are you going to need extra materials for the caulking application? In this case, probably not. But if there was, this is where you would add them. All right, so now we're talking equipment. So this is where we are going to add. So as we said, we plan to have 2 swing stages for 2 months total. So that's basically 4 months of swing stage, right? Rental, if you go to each. So what we basically have is 4 months worth of an individual swing stage rental. So we're going to plug that in at 4. And we're assuming $2,000 a month. Various markets you can rent for, anywhere from $1,500 to a little over $2,000. So I'm just erring on the side of caution here, putting in $2,000, but adjust it for what your market is. All right, overhead protection. So we went through this before about the assumptions we're making. So we said the setup and takedown is $58,750. So in this case, I'm just going to put that in as a lump sum. $58,750. Because we already calculated that. And then the overhead protection rental. Well, we said that it's approximately $16,450 per month. And we know that that this number includes the first month. So that's why it's so advantageous, especially when you look at these costs, to get the job done as fast as possible. We're still within a good margin of that 2 months. We might be cutting it close, especially if we had a weather delay. So, but let's be aggressive on this, and let's only put in 1 month, because obviously that's only 1 more month. If that was like right at 1.9 or 2 months, you might add in a little bit of fudge factor in case you run over, because you're still going to have to pay. All right, are there any other equipment costs? Aerial lifts, generators, fuel. Sometimes you need to use, generators and fuel to power equipment, swing stage equipment even. But let's make the assumption that, we can get power from the building up on the roof. Maybe, typically these are 240 volt setups where you can attach into the existing electrical panel. And let's assume there won't be any additional costs for that. Or what we could do, additional equipment, we could basically come in here and say, well, we might need an electrician, for a few hours there, or an hour to install, into their unit. We can put on $750 here just to cover us. Subcontractors and miscellaneous. As I said before, even if you're going to use, say, a small subcontractor to perform all the joint sealants for you, this is the cost of labor. So if you have a qualified sub that can do the rigging, that can do the caulking, obviously, and I've done this in the past, I will provide the swing stage, I will provide the materials, and he will do the rigging, he will do the wet glazing. So basically, I have a budget of $60,000 here cost. If I could sell that to him for $60,000, that's the goal. In that capacity. So basically, and this is kind of where you sum it all up. So what sort of margin are we anticipating here? Well, from my experience, if you're doing smaller projects, sub 25,000, you typically are looking for, trying to generate revenues over 50%, even over 60%, depending on the case. Larger projects like this, you can see we're already, in the, $300,000 range here. Most likely you're not going to be able to attack it with margins over 50%. But I typically don't like to drop below 40% in this business-to-business commercial property management world. So 45% is typically the norm. I try to hit on this. Maybe we want to be a little bit more aggressive on this. We can play around with a couple numbers. So I've calculated this so you don't have to play with these. You just mess around with the percentage, and you can kind of see the difference between, say, 40% and how much you would make as far as gross margin dollars on that versus, say, 45%. And then relationships often drive price too. If you have like a last look and and they say, well, the other guy came in at 325, where would you need to be for that? You can see, well, 42% would get you close to that. So that's kind of how it works in a nutshell. You have at 42%, your total cost 189 means you make 137,000 in gross margin dollars on a 325,000 ish project. So I know that was a lot to take in, a lot of numbers there, and estimating is definitely not a guess. It's definitely a science based on predictable outcomes from experience. And as all BEG members know, I'm here for you to help and train, and especially if you get into some complicated projects, myself and the team, we can, help you try to figure out what the best attack plan is to try to be more economical and productive and make the best profit possible. So I appreciate your time in this, and as usual, feel free to call me, say hello, shoot me an email with any questions, and I'll be happy to get back to you just as soon as possible. Have a great day.